We're discussing Flyte signaling and gate nodes here. For those who don't know me, my name's Dan. I am a software engineer with the Union team. I work mainly on back-end type stuff, Flyte Propeller, Flyte plugins, kind of everything encompassing actual orchestration of running workflows. So first, kind of dive into defining signaling, seeing what signaling is. We're referring to the ability to pass kind of arbitrary data to a running workflow. This work has been driven by human-in-the-loop use cases, foremost of which is approving data before any kind of subsequent processing. So things like you had a task A, for example, that produces a data set that's then processed by task B. A user with some kind of esoteric knowledge can come in, look at that data set, see if it looks good or a value as a result of task A, and see if they want to continue running that workflow or if it's just not worth it. Similar use case could be labeling data for supervised learning. If task A outputs a data set, you need somebody to come in and label different rows or data in there before subsequent processing. You can do that. Both of these use cases are passing just a Boolean value of like approving or disproving it. But we've kind of taken this a step further to say we want to be able to pass arbitrary data. We want to be able to pass things like collections of data or maps of data of any kind of data type. So a use case for that could be something like dynamically defining task parameters. You could, a user could conceivably at runtime of the workflow say, hey, let's run this with this value downstream after seeing some of the output of previous tasks. And there's just a ton more use cases for this work. A very brief outline here. I'll try to make this as quick as possible while providing the most information. But we'll dive into the backend implementation very lightly. I think it's important to do this because right now this has been fairly clear and straightforward. We're working on kind of the user experience and the UI work. And so backend is mainly done. We think it provides a very flexible and extensible support, and we're kind of looking for some level of input on FlyteKit API proposals, how we want to present this to the user to make sure that we are encapsulating all of the functionality we have, and it's flexible and extensible enough for users' use cases down the line. So kind of the foremost implementation on the back end for this is the introduction of a gate node into the Flyte workflow, into Flyte IDL. So Flyte constructs a DAG, for those who don't know, a DAG of all the operations. These are different nodes within the system. We have things like dynamic nodes, branch nodes for conditionals, task nodes, execute any kind of plugin that you're running, and then start and end nodes anchor this. So this work adds a gate node definition that is a first-class citizen. And gate node is really just contingent on a single condition. It takes inputs just like any other node and it writes outputs. But when executing that node, there are a condition of right now signal or sleep that defines if that node is successful or not, or if it should keep going. The signal condition we define as just a unique ID to the workflow. When it's run in the global scale, we concatenate that with the workflow execution ID to make it unique. And then a data type. We are storing that as a literal type in our Flyte IDL proto message. And so it's important to note that this supports all kinds of data, primitives like integers or strings, supports collections of data if you want lists of values, maps, and you can nest these things as well. You could have a map where a value is a list of data. So very, very flexible on what you can pass into the workflow as portion of a signal. And then the sleep condition just requires a duration. This would be something just like, here's a node, we want task A to run, and then 5 minutes later, we want task B to run. So in between those dependencies, we could put a gate node with a sleep condition. To get signaling to work, we've added a SignalService onto FlyteAdmin. I think that this is a perfect spot to add it into our framework. FlyteAdmin is kind of control plane for executing and managing execution of tasks. And so the SignalService is just a gRPC service, just like every other service that's offered in FlyteAdmin. A quick kind of dive through about what execution of a gate node with a signal would look like here. We have Flyte Propeller in the bottom right that has some kind of workflow DAG with a gate node. Without diving too deep into Flyte Propeller, we iteratively process that workflow. When it gets to a gate node, it will contact FlyteAdmin to check if that signal exists based on what the ID is. FlyteAdmin is able to store all these things persistently in a database. And if it exists, meaning there's a value set for that signal, then it can use it and progress down the workflow. If it doesn't, it just waits until the next periodic check of that workflow. So users are able to kind of trigger a signal using a number of different APIs. Being a gRPC service is very slick and seamless. There's support for HTTP endpoints through that. They integrate very easily into gRPC. And then additionally, we can contact like FlyteConsole, where there are specific buttons in the UI to say, okay, signal with this value to this node. And then that on the back end goes through and contacts FlyteAdmin and sets it as well. So the back end we think is extremely extensible, very, very flexible. The problem that we're running into right now, and I wouldn't say a problem, more so an active discussion, is what is the correct level of abstraction and the correct way to present this to users to ensure that there's full functionality, but not being unbelievably verbose in that. We've kind of come up with two different ideas that we've fleshed out over quite a few discussions. Specific syntax has changed, but just try and look at like the overarching ideas between this async await proposal and chaining IO proposals. So an async await idea of implementing signals and gate nodes in general kind of attempts to emulate popular async frameworks. These are extremely useful in things like Python. My experiences with Rust on the back end. But the idea is that we can define signals explicitly, and then those have typed values. So in that workflow, the first workflow, signal workflow, we say we run task T1 on the A input. We then define a signal that's of type Boolean. There's a timeout and a name if we want to specify that. And then we're able to, in this conditional, say, okay, if V is true, v.wait, that's what's called as part of the async API, then down the line, we could process that B value. This would say, execute task T1, wait until a user approves that value, and then process that down the line. Similarly, for something like a sleep, we can use promise chaining, which is already available in the FlyteKit API, where we can call Flyte sleep on something and wait. That would return a promise of like a none value or something like that. And then for the T1 task to execute, we can use promise chaining with V, inject kind of a dependency there where we say we have to sleep before B is executed. The one problem with this that we're seeing is this maybe not enough abstraction for use cases. It's certainly very flexible, but we don't want to have an API that's too verbose where users don't understand what's happening and just kind of thereof expressing that cleanly and ergonomically. Another kind of competing one is chaining IO. So the FlyteKit API, if you look at it from a high level, it kind of implicitly defines the workflow DAG using IO flows. You execute a task that returns a value, you pass that value to some other task, and that defines what the dependencies between all of this data is. So in this one, you have something like a flight.approve over the data that takes then a value as part of that function call and returns another value. So we'd execute task T1 returns B, we call approve on that, and then we can use that conditional again to say, okay, was B approved or was B not approved? And then this would very, very explicitly inject that dependency into the Flyte workflow DAG of saying run T1, then have a gate node with a single on it, and then we can process downstream from there. Similarly with the sleep call on that sleep workflow at the bottom, we could have something where sleep and you'd pass it a value to say, don't make this value available until we've slept on it. And then we have T1 call that is then over the result of that sleep call. And there's a little bit of concern with this as well. Is there a lack of flexibility here? How do we integrate support for arbitrary type signals? I think that there's a lot of power in being able to say, hey, I want to pass it a map of strings to Boolean values or collections of data. And I think there's some things that we can do in the API to make this a little bit cleaner. So maybe this is too much abstraction, and maybe we need to, expose those internal APIs a little bit deeper. I'll talk about it a little bit more at the end as far as input from people, but we're very much so looking for input and seeing what kind of use cases people want, and make sure that we can capture this cleanly in an API that for 90%, 95% presents a very ergonomic API. But then covers feature complete for the rest of it, maybe a little bit more verbosity, but still very powerful. We'll look at in Flyte Console. There's a brief preview of kind of how this may be presented. Kudos to the front end team. They've drawn up some very beautiful things that I've just butchered. Take little snippets of them and throw them into my slides here. But the idea is that if you have a lot of workflows with signals, we don't want those to get lost. I think it'd be very easy to say, hey, you don't know what's running or what's blocked, and then those would time out and fail. So right on the project page in Flyte Console there, at the top, you can have this paused expandable button here, where that would fill out. Here are all of the tasks or all of the workflows that are actively being paused and waiting for a signal to be sent to them. Probably can't see it, but in the right one where it's expanded, there's a little bit of a play button right here. And we'll talk more about that in the next slide. Where similarly in the node and task view, you'll be able to dive into a specific task and say, okay, this task is paused in that upper graphic. And then there'd be a description that would say, hey, paused on signal with whatever the signal ID is, waiting for a type, whatever the type is. And we see in this one that this is actually a sub workflow, so that label of being paused can propagate up to the sub workflow on top, because overall that sub workflow is being paused as well. And you have this similar button that is a resume button there on the right. When you click that, you would get something like a pop-up that would say, okay, here is the task that's being waited on. Go ahead and enter an input value. And then you can send a signal to the backend through the UI that way, and progress with the execution. So quick roadmap for this work. The backend implementation is functional. IDL, standard lib, propeller, admin, there's PRs out for all of that. So I kind of snuck away from doing a demo here. It would be a lot of terminals that may not be terribly interesting to people. So something a little more graphic, I think, was a little bit better. The UI work is in active progress. I think these previews look fantastic. I think it captures the idea well and presents it in a kind of an ergonomic function. And then the FlyteKit API, like I said, we've been going back and forth with kind of what is the best way to do that. And for me, it's sometimes difficult being a mainly back-end guy that maybe I don't have the experience on how people are going to use this or what people want out of this API. So would love kind of any community input we can get. The RFC is a great place to make comments on that. Otherwise, if we want to just talk about it in feature discussions a little bit. But yeah, we'd love to discuss this a little bit further. Questions, if we have time.
We do, for one. If nobody has a question, I have a question for you, Dan. So where do you see this in the future, in a year from now? I mean, what do you hope people are going to do with it? And maybe tell us a little bit more about the vision beyond that.
Sure, absolutely. Like I said, the main reason for implementing this has been a feature that I think people have been looking for quite a few years. If you look at the actual issue for it, I think it's like 3 years old or something like that. But just the human in the loop tasks, just being able to approve data or pass in parameters is very easy and very useful. But moving forward, we tried to implement this in a way that, with this gate node that is contingent on a condition, as part of the Flyte ecosystem, we can integrate, different conditions into that, and hopefully kind of build out some more robust functionality in this gate node than just sleeps and signals. There are conceivably a number of different use cases that might be useful for blocking a workflow.
Great, awesome. So wonderful. I think it's good to have the feature discussions in the Slack channel. So I would just say whoever sees this, watches this on over social media, engage with Dan. I think there's a lot to dig in, and I'm looking forward to getting this implemented and rolled out completely.